Do you have that? So what's the topic, Faisal? Standing waves?
Yeah.
Okay, can we see? B5, part A3. Okay, let's have a look at that now. Go for it, Faisal. Read it out to me.
An experiment to measure the speed of sound.
Yes.
Note of frequency 512. Was sounded above the open end of an air column closed at the other end. The first position of resonance occurred when the length of the air column was 0.162.
0.162.
What is the length of the air column?
Ah, but you just said the length of it.
Yeah, but what does it mean?
Oh, that means this length.
And it's an open end.
Yeah.
So
it's a wave like this.
Yes, they asked us to draw in the first part. I did it.
Yeah. And
then determine the speed of sound in the air column. This is the length of the first position. And then they give us the length of the second position.
Okay, there's two pictures then. Is that what you're saying? So the next one then is what length?
0.494.
0.494.
The second position of resonance occurred when the length of the air column was 0.
That's the second resonance.
Yes, the second position of resonance.
So that would be, my goodness, it goes 3/4.
So the first position of resonance is like the first harmonic?
Yes. Now,
it's the English, it's not the physics that I want to do.
Yes, yeah. But even the physics here is a bit tricky because I don't know what do we do next. You see, we have this formula V equals lambda F and V equals lambda F. Do we know, or we want the V, do we know the lambda? Well, we can know the lambda, right? Because here
we know the length of the column.
Yeah, the lambda will be 4L.
Yes.
And here can we know the lambda? We can.
3 over 4?
4 over 3. Lambda. L. So, tell me this. Why have they given us two pieces of information? If really we only need one.
Because it's changing?
No. Well, we know the F.
Don't know.
The reason is, if you look later in the questions, they ask for the error correction.
Determine the end correction of the error.
Yeah. So what's happening here is, in this experiment, we said lambda equals 4L and lambda equals 4 over 3L, but it's not quite exactly that. There's an error that we have to add. It's not going to be perfect. Yeah? Does that make, I think we talked about this in one of them. So what's going to happen is we're going to have two variables, V and the error. And we can make two equations and we can solve for both. So let's try to do that. So the reason for the error is because, well, there's many reasons, but it means it's not a clean exit at the end here. So the wavelength we think it is, we're wrong a little bit. And likewise here, we're wrong a little bit. Yeah? So in this formula, we have V equals 4L plus E, and here we get V equals 4/3 L plus E, F. What number, can someone tell me 4L please? This is L? I'll just do it in my head, it's quicker. And here, 4/3 of this number, 0.494. Yeah? Like this?
You can write out 659.
Thank you. 659 plus error 512. I think I did something wrong here. No, I did something wrong. Oh, rats! Should add brackets here. That's okay, I'll fix that. V equals 4L plus 4E, 512, and V equals 0.659 plus 4/3E, 512. Okay, so Faran, can you just multiply this by 512, and Yusuf, can you do this one by 512? 331 plus 1024E, and Yusuf?
337.
Yeah? 0.4408?
Yeah, no, just 08, without the second 4.
And then, what is 5/12 times 4/3? Wait. 682. Yeah? What is 2000?
512 times 4E. No, this is
4/3.
This is right, the previous one.
Plus
682.667. You want 3.
yes. E.
Yeah, the first
512 times 4 is 1024, is it not?
No.
Oh, sorry, of course it's not. 2048. Okay, so now we have a simultaneous equation. We have V minus 2048E equals 331.776, and V minus 682.667E equals 337.408. Now we can get the V and the E. So, do I have my calculator open? No, I don't. Could someone just use the mode on the calculator to get the V and the E here, please? I'm expecting the V to be nearly 340, or 335 or whatever, and the E to be about 0.01. 340.225. Okay, and E?
4.1 times 10 to the minus 3.
4.1.
Times 10 to the minus 3.
Now what is the actual answer? And how many marks was this?
Finding the
Both, yeah.
It's 4.
4,
Yeah.
and the E?
The E is 2.
So 6 marks? Okay. But it's hard.
What question is it?
This is B5, part A.
B5
Can you zoom out?
B40 and 0.001. Yeah.
I got the exact answers? Sweet.
Yeah, it's 4.1 millimeters.
What's the next one, Faisal?
The next one was the moon and sun that we did.
Okay, great.
People. Heat capacity and loss.
Okay. And then is that it?
There is two parts in this question.
Okay. Oh, sorry, can I continue?
No.
No. Yusuf, this is okay?
This paper, there is like 5 of its questions in your questions that we get by the end of each lecture. Good paper to practice, not to do for the final.
A good cross section, good. Can I scroll down? Yes, please.
The definition of difference between the stationary
Yes.
wave and transverse
Yeah.
are different.
The definition of wavelength?
Yeah.
No, do you mean because of this? The E? You don't like this?
Transform.
Yeah.
Like, but
Be-
the wavelength is between two peaks.
Yes.
No, yes. It's different for the stationary wave, yes. No, you're right, it's between two peaks. But for a stationary wave, it's different.
Two nodes. Antinodes of two nodes.
Yeah.
And times two.
Between two nodes times 2, yes. Yeah. Can I continue? Okay, Faisal, give me the question.
Determine the quantity of heat required to raise the temperature of 0.5 kilograms of ice at -5 degrees to turn it to steam at 100 degrees. Heat capacity of ice, heat capacity of water, latent heat of fusion of ice.
They're all given to you.
Yeah.
Really, this one?
Yes.
For reals?
Yes.
Okay.
Yeah.
For reals, alright. So, what happens here is the ice goes from -5 to 0. And then the ice becomes liquid water at 0. Then the water becomes water at 100. And then it finally becomes steam at 100. So there are 4 calculations to do. So number 1, number 2, number 3, and number 4. Ice going from -5 to 0, that's mc delta theta. What is the heat capacity of ice, please?
2.1
Yeah.
exponential 3.
Right, now ice to water, that's the ml, that's the latent heat,
What's the 5 on the right?
the delta theta, 5 degrees, mc delta theta.
Okay, yeah.
Now ml, what's the latent heat of fusion of ice?
3.34
Times,
10 power 5.
okay. And now water from 0 to water at 100 is 0.5, they use 4120,
1.8.
4.18
4.18.
times 10 to the 3
Yeah.
times 100.
Okay.
And then lastly, the water becomes steam, which is ml, and latent heat vaporization.
2.26
Yeah.
10 power 6.
So calculate these four and add them up. How many marks?
4.
Too many marks. So what went wrong for you?
No, no.
So MC doesn't see here.
I don't. It's not even a question. What?
Yeah, I know.
What? Give me a full question. Is what MC delta theta?
M is 0.5. What
Yeah.
is C?
It's different for each step. For those two steps, I use MC,
Okay.
and then for this step,
Yeah.
yeah. There's 4 steps. Can I continue? Continue? I have to continue now, come on. I'm continuing, Faisal. Give me the next question. Faisal?
Yeah, the next one is it's still B3 part B.
Yeah.
Oil law and okay, it's kinda carry through. The first one is they give you the mass of oxygen and then enclosed in a container of pressure, and they give you pressure, temperature and mass.
Okay.
And then they ask you to find the volume of the container,
Yes.
and then they change the pressure and get the new volume.
Yeah.
And then the last question is determine the density of oxygen.
Okay. So what part do you need to do? The whole thing?
The last one.
Determine the density of oxygen.
Yeah.
Okay, well the density is mass over volume.
Okay, you have the mass.
Yeah.
They don't. The new volume of the gas, if the pressure is increased to, you're supposed to find the volume basically.
Yeah.
In the beginning parts.
Yeah.
And the pressure is 1.01.
Yeah.
10 power 5 Pascal.
So what do you need me to do exactly?
Determine the density of oxygen.
But it uses the 2 answers which you said you can get, because you said you only need the last part.
Yeah.
So you know how to divide, so what are you asking me?
I didn't get the right answer for the last one.
Did you get the mass right earlier?
Yeah.
And the volume right?
Yes.
Okay, so tell me what the mass is.
The mass, I did the math wrong the first time.
Okay.
Because they give us the MR.
Yeah?
I didn't know that we have to take power -3 for the MR. They give us the mass in kilograms.
Yeah.
And then they give us the
Okay,
MR.
let me just do the whole question, it'll be easier. Right, start from the beginning.
State Boyle's law, the first thing, and then the mass of oxygen is 0.575
Mass of oxygen 0.575 kilograms, okay?
kilograms. Enclosed container of pressure 1.51
Atmospheres.
times 10 power 5 kilopascals.
Oh. 10 times 10 power 5 kilopascals. Okay?
No, just pascals.
Okay.
Temperature 10.
Celsius, obviously.
Relative molecular mass of oxygen.
Wait, let me just put this in Kelvin.
Yeah.
Okay.
This one too.
And the molar mass?
The relative molecular mass of oxygen is 32. No, that's it.
Okay.
Okay, determine the volume of the container.
Right, now don't say anything, we'll put it to the class. How can I get the volume here for this problem? What can I use? What formula?
PV equals NRT.
Yeah, so V is nRT over P. Yeah. Now, before we start, let's see what we have. Do I know or? Yes. Do I know T? Yes. Do I know P? Yes. Do I know N? No. The molar mass is 32. This means, the definition of molar mass, relative molar mass, is that you require 32 grams of oxygen before you have a mole of oxygen. So if 32 grams of oxygen is required for 1 mole of oxygen, then the N will be 575 over 32. So if you type in 575 over 32 times 8.31 times 283 times 1 over the pressure, which is 1.51 times 10 to the 5, then this will give you the volume. So it's that, multiply that, divided by that. So can you multiply those 3 numbers and then divide it by those 3 numbers then? Okay, what's the next question?
Yes.
Yeah, B. Yeah. What's the next part?
The next part is determine the new volume of gas if the pressure is increased to 2.51.
Okay, so if the pressure is increased, what's it, to 2.51?
Yeah.
10 to the 5.
You just replace it in the formula and then you get the new one.
Yep, or, Faisal, can you type in 2.5 times 10 to the 5 divided by 1.51? Please just tell me that.
Yeah,
Just tell me it. I don't need you to speak. Just tell me it.
$3.77.
Thank you. So, what has happened is the pressure has increased by 3.7. Did you type this in like I asked you to?
It's 1.67.
Thank you. That sounds more like it. So what has happened is the pressure has increased by 1.67 factor. So that means if the pressure has increased, what happens to the volume? Decreases by the same amount. So your 0.28, you just divide it by 1.67 and you get
0.166.
And is that the answer? Great. So what is the last part now?
Determine the density of oxygen. Oxygen gas at STP 0 degrees Celsius and 1.01 times 10 power 5 kilopascal.
Okay. So it's mass over volume. The mass you know.
What do I know about that?
You know that you will have 0.5
5 kilograms of oxygen.
Yeah.
Okay.
And the volume you'll have to recalculate because the pressure is different.
Okay. So just replacing with some the top
It's doing the same thing 3 times. Really. Yeah?
What 3 times?
It's the same formula.
Yeah. PV equals nRT will do.
Yeah, I know. No, you said it's just 3 times. What do you mean 3 times?
It's like the 3rd time you would have used the PV equals nRT formula.
Oh.
It's the main point.
It's the only part, really. Right, Lee, you had a vector question, wasn't it? Huh? Proof, yeah. What was it that you wanted me to prove? Which proof? Proof what? Do you remember the question?
That was the square and
Prove that
that
if the diagonals of a rectangle are perpendicular, then it must be a square. Yeah. Cool, let's do that. Can I scroll down? Vector proof. We want to prove that if these are perpendicular, then it must be actually a square. That's what we're trying to prove, yeah?
Thank you.
It's a good revision year, 2015, version.
4.
Are you doing all the versions?
For now, no.
Okay.
From year by year.
Huh?
Year by year. For
Year by year. Okay, so we'll have to give them some points. Let's just call this 0, A, B, C. Now we're trying to prove if these are perpendicular, then it must be a square. So if we know, it's known that they're perpendicular, what is that statement as a vector?
Dot,
Dot, yeah.
0.
Dot what?
OC and BA or BB.
Yeah, OC dot AB or BA. That must be 0. Yeah? Now, let's have a look at this first one here, OC. I want to write that as a sum of two vectors. What two vectors add together to make OC? OB plus BC, yep. Or we could also say OB plus OA.
Can't we make it A plus B?
Yeah, which is what I'm getting to, which is going to be just A plus B. Now, what is AB?
B minus A. Nice.
Nice indeed. So this will be A dot B, yeah, minus A dot A plus B dot B minus A dot B. Now what happens here?
AB cancels.
And what's A dot A?
A squared.
And this one?
Magnitude of B squared.
So magnitude of B squared equals magnitude of A squared. So the magnitude of A equals the magnitude of B, which is a square. These are the same lengths.
Nice.
You like that, Lee? You like it, I know you like it. This is the silence of amazement.
No, acceptance.
Fuang, it's only a fly, it can't hurt you. Seriously, it can't. So it's the silence of acceptance.
Like, oh, exams in 2 weeks. Let that sink in.
You have all of the weekend to let that sink in.
Yeah, I know. Anyone else have a question?
Yeah, wasn't there another math question? Exam.
Practical problems. Or we just don't understand.
No, it was the exam I said I'd do, wasn't it?
Yeah.
Yeah. I don't remember what year I opened. Someone wrote it down. I think you actually wrote it down, Yahya. Thank you, Fuang. Tired?
Why can't chemistry be like this?
Like what?
Like math and physics, where you practice and you get it.
Yeah, that's why I don't like chemistry.
I don't have to read the book before I start doing physics for physics and math.
Yeah, you just do it.
Chemistry is stupid.
Past papers. We are doing maths. And you said 2015? And what version? Oh, there's only one version. Okay. Let's have a look.
You don't want to plug your laptop to the charger?
I think we're good for another 19 minutes max. Right. Part A, I would hope, was fine. Let's quickly do it. So, what's the formula here for part A? Yeah, A plus TAB. So, what answer do we get here? We get P plus T PQ.
Yes.
Okay. What is P here?
3 minus 4, 2.
Okay, and what is PQ? Q minus P. 7 minus 3 is 4, isn't it?
4 minus 2
And, yeah?
and 1.
T. So this is the answer for the first one.
Yeah.
Good. Right. B. Show that minus 9, 2 and minus 1. Very good. Is on this line. So Yahya, what did you say? You make it equal. And you should find a T that makes it. So if you look at the last one, it's pretty obvious. What must the T be if you were to look at the last one? Yeah. So if you make T equal to minus 3, we'll get 3 minus 12 is minus 9. Good. Minus 4 plus 6 is 2, and minus 1. So therefore, it's true. C. Show that this is on what? Point S is on this. Ah, okay. This is S. Write down in P an expression for OR S, and this is OR here. I don't want to use OR again, so let me just change this original. Yeah, but we have to give it a vector, so we'll call it. No, they used P already. We need a different letter. N will do fine.
M.
Okay. M. Right. So next we want what is it? OR S? Yeah, OR S. How do we find OR S? S minus R. So that's P minus 10 minus 9, P squared minus 2, and then P minus 2 plus 1 minus 1. I think I got this right. Huh? Oh, thank you. Plus 3. Thank you. Is that it?
No.
Well, for that part, I mean.
5 marks.
OR S is perpendicular. Show this. Okay, so OR S is perpendicular to M. So that means this dot, what we had earlier, yeah, 0.
0, 2,
Yeah.
or
But
Where is M?
no, you can get a line on the a vector on the iPad.
thank you, sorry, I just realized I screwed that up. It's not this vector we use, it's this one. Because remember, like in the question with getting the angles, when we want the direction of the vector, we use the coefficients of the t.
Again?
Remember when we were looking at angles,
Yes.
a plus tab? Which part of the vector line do we use for defining the angle between lines? The AB part. This is the direction part. So likewise, when we're talking about perpendicular, we use the AB part. So I should have this. So that means 4p minus 4 minus 2p squared plus 4 plus p plus 3 equals 0, minus 2p squared plus 5p plus 7 equals 0. I have a sign mistake somewhere, don't I? Something wrong with my constant.
Where did the minus 4 come
Oh,
from?
sorry, minus 4 is from minus 1 times 4. Minus 4 plus 3 plus 4 is 3. So we get 2p squared minus 5p minus 3 equals 0. Correct.
Go back. Can we zoom out?
Wait, that was 5 marks? Wow,
You
no.
have to find the values between.
Oh. So much. Can I factorize it? Let's factorize it. 2p, p, 3,
2.
1.
What one? You won't get one.
I did be. Oh, grateful.
That's 1 minus 3.
And this is a 3 here. So this is minus and a plus. Yes? So p is minus a half and p is 3. Now I have my 5 marks.
Zoom out, please. More.
Next, D. No, that was D. E. Find S. Am I doing? Hang in there. Let me turn the brightness down on my laptop. Find S. Oh, goodness sake. Right, so you just take these two values and put them back in here, and you have S.
We'll have 2 S's.
Find the two possible coordinates of point S. You will have 2 S's.
I'll just make
You know what else has 2 S? What? Yeah?
I'm just making it clear for all.
Okay.
Okay, next one.
Guys, I don't need to find the 2 S's, do I?
No, you don't.
No. F. Show that this line is parallel to the line we had at the beginning. Okay, so 3 minus 4, 2 plus 4 minus 2, 1 t is parallel to 3 minus 5 and 8 plus
Minus 12,
yeah,
6.
and minus 3. How can I show these two lines are parallel? Well, what does parallel mean?
One is a t scalar in the question. Where t is a scalar.
Because it is.
Okay, yeah.
They shouldn't be equal to 0, but the ratio should be.
Thank you, Lee.
Alright.
To show that two lines are parallel, the direction vectors must be the same, except one of them could be bigger. You don't care if it's bigger because that's still the same direction. So you want to show that the direction vectors are, as Lee said, how did you say it? Can you give me a full sentence?
The ratio, like, I can't quite visual to each one.
A multiple.
That's the way, yes. That if you want to show that they're parallel, you need to show that this is a multiple of this. Well, it is. It's 3 times it. No, sorry, minus 3 times it.
Yeah.
And that's enough. That's all you need to say. Yeah, because think about it. If this vector is 1, 1, 1, and this vector is 2, 2, 2, do they point in the same direction?
Yeah.
They do. It's just the size is different, but you don't care about the size.
So
Yeah.
we just say that
The direction vector minus 12, 6, minus 3 is a minus 3 multiple of the direction vector 4, minus 2, 1. Therefore, they point in the same direction. Therefore, they're parallel.
that's it? Or is there another part to it?
That is it.
Nice. That was a nice question actually.
Perhaps for you.
Perhaps if you did it.
Perhaps. Now, how many topics are left in the maths and how many are left in the physics?
Physics I think is just one.
How many subtopics then?
Okay.
I know there's one chapter left.
We don't
If
know
your
what we
teacher
haven't
did not
studied
know how
yet.
many chapters are left, there will be a problem.
We don't know what we haven't studied yet.
I can check.
Thank you.
For Thursday.
Yeah, how many worksheets?
2, 3, 4, 5, 6, 7.
7. Dang. 8. Dang. And how many for maths in the maths one? There's just the last topic, the probability. It's probably like 3, is it?
Yes.
It's 3? Yeah. is 3. So in total we have 11 topics. How many hours do we have next week?
There's
6 of each.
6 of each?
We're not doing statistics.
No.
I don't think,
They added.
don't we have,
We have,
Omar, if we have more than 6, that's better.
I think we do, because, on Monday we have 4 hours.
Sounds wonderful.
or Tuesday we have 4 hours.
Sounds wonderful. So, we have 11 topics to cover in maths and physics, and we have at least 12 hours. So, next week will be more physics than maths, because we have more physics to do than maths. Yeah? I think, I don't know if I want to do all the physics and then do the maths at the end of the week.
We have 4 hours of physics.
No, you don't like this idea? You want the maths mixed in?
On,
Yeah.
Yeah?
on Monday we have 4 hours, like, on Monday it's only 2 hours in the